Okay. Okay. So I just sent you the link to this problem in the chat window. Can you see that?
Yeah, I got it.
Okay, so the problem is, let me read it also. Rat in a maze. So let me see if I draw. Yes, okay. Perfect. So the rat in a place is basically you have a grid, and in this, so in this particular grid, there are different ways of getting along. So for example, this one in the one particular case is what did they say? So basically there's a rat standing here. You can see my iPad, right? Yeah.
Yes, yes.
So the rat has to get to somewhere, or no, rat has to get to the endpoint, M endpoint. So it can, like for example, it can come, so it can come here, it can turn. So it's basically gonna go hit this top, and it cannot go through that way. So it has to come back and keep going. Even again, might go to top, hit, come back, and finally they will get there. Okay, so some kind of a the grid search problem. Okay, so here the question is, consider a rat placed at 0, 0, 0, 0, in a square matrix of order n cross n. It has to reach the destination n minus 1, n minus 1. Find all possible paths that the rat can take to reach from source to destination. The directions which the rat can move are up, down, left, right. Value 0 at a cell in the matrix represents that it's blocked. So if this is 0, it's blocked. This one, let's say 1, 1, 1, 0, 0, 0. Oh. Should I use a different color for that? Take a second. So okay. Jump. All right, so the rat has to come very smart. So here, the cell it cannot go, so it has to come back here, and it gets here. It can go to the cell, and if it cannot go to cell, it's called 0, right? Up, down. Value 0 at a cell in the matrix represents that it is blocked, and rat cannot move to it, while value 1 at a cell in the matrix represents that rat can travel through it. Okay, I think we got it right.
Yeah.
Okay, rat in a maze using backtracking. Okay, so let's start solving this. What am I doing? Perfect. So let's start standard steps. No comments. Okay, so paraphrase. Same thing, we'll also try with all the same, and I mean, we can even try it with what is this called? The same idea of start with recursion, eventually do it again.
Okay.
So maybe for starters, we can even make it a simpler question, which is paraphrase me. The question is, find if there is a path or not itself. Okay.
Right. Yes.
If you find it, printing is the easy part. So paraphrase core logic, dry run, what else is next? Edge or null cases. Sorry, life is online editor. To read out loud. Okay, so core logic is this. So let's start with recursion. So just to remind you, our goal is to start with recursion. Then we will add some data structure that will become memoization. And from there, memoization, we add another iteration, and that becomes DP. Okay, so let's see if we even have to go there. So core logic, what is the first step?
First step would be, check if 0, 0 is a
No,
1.
recursion ka first step.
Oh, okay. A signature.
Okay. Second step.
Um. Me, my.
third step?
Um, Call recursion, like parting gift. No,
Yeah, but that is
last
for
thing. Uh, e- Edge cases, exit condition.
exit slash base case, whatever they call it. Okay. So, okay, so let's say in this case, we want to start with, let's start with the function signature. So we understand, let's call it find path for now. So find path, maybe what we are doing is, let's call it public static bool. Bool is enough, right? So let's put bool find path. What we will get is, let's say you're given grid. It's probably can be global also. What else do we need? Same m comma n. Okay. So let's say you're given that this, we can probably make it this also. Okay, so we wrote the function signature. So now let's talk about me, my, right? So another color if I can find. So let's say the rat is staying here in this place. And now it has choices like top, uh, top, bottom, left, right. Okay, from anywhere it can go left, right. So let's say it starts with the top, it goes this way. Okay, hits an emptiness. So comes back here, right? And it theoretically, if you write it top, bottom, left, right, it can still go back there to where it came from. Now, at least right, we know we'll give you exit, and this we know is the right answer. But even before that, if the cat goes to left, this will keep going in an infinite loop. Okay, goes to left and this guy's right will keep going here. So now considering all that, how can you find the path?
Can you talk about the infinite loop once again?
Yeah, so 1 second. So so what I said was initial, this cat, if you look at the question also, rat has 4 options at every cell, right? It can check, it can go either left, right, top or bottom. Okay. So let's say it is standing here in this cell. It tried doing top, we went to top, right? And in this case, okay, let's order is also different. Actually, let's change the order. Let's say it is top, left, right, and bottom. Doesn't matter, but it'll be the same problem I encountered one way or the other. So it went to the top. It found that, okay, there's no way out of there. It comes back to where it was. Now, as per the recursion, this will be L. So L is where it came from. So it went back here. Okay.
Right.
So wahan pe, at that point, if it recurs again, it will be TLRB. So it will go top, no, left, no, bottom, yeah, maybe that'll keep going. Again, it's already going back. That's a bad idea. It'll again go right. So right, matlab it's going back to this place. So for all you know, this might just get in an infinite loop from
Right.
this to this cell.
Right.
Okay. So how can we do it?
So we can have a visited matrix which will keep a track of the visited uh, coordinates in our current path so that we don't visit them again.
Okay, so let's then we need a helper function. Probably should write helper function. Yeah. Okay, let's call public static void helper, and this is where you wanted this is empty, so we'll just create a grid, or actually let's call it def helper itself. So since our goal was to just tickle our brains, let's start. We got the rough idea of the function. Def helper इसमें so what I'm saying is this one we need to create a grid first. The grid is equal to something something. So M is equal to length of grid of 0, N is equal to length of grid of 1, and you're saying we can create a set, is it?
Visited, yeah, probably a set also we can add the coordinates or a matrix. Anything is fine, whatever you are comfortable.
Okay, let's call it a matrix for the sake of argument. Okay. Okay. So then it has to call the find path, right? So in find path, it will, so we just print bool if there's a path or not, find path of grid, comma, m, comma, n, comma, visited. Okay. So then let's go back and change this guy. Okay. So visited. So that is, we could have made it global also, but that's not the tough part. Okay, so now what do we need to do? Let's again start with the idea, right? Me, my. So remember, remember this whole idea about Fibonacci. The Fibonacci is, let's say this is bottom, this is top, right? So when we build, so this is, let's say, the actual our original what is it called? Fibonacci is 0, 1, 1 plus 0, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5. Okay, so those are the values. So recursion is top down. So what recursion says is give me fib of 0, 1, 2, 3, 4, 5, fib of 5. So if then it goes back, fib of 4, fib of 3, fib of 2, fib of 1, fib of 0. And at fib of 0, we exit. So exit and we say, okay, the fib of 0 is 0 and fib of 1 is 1. We go back, right? That's how recursion works. Caching, on the other hand, is going to be bottom up, right? So you have to start with 0. Everyone, you'll add the previous value, you build it up and whatever. And then you return it. Now, given all that, how will you, what will you do with, okay, let's start pure recursion for now.
Okay.
So pure recursion may, what we did the function signature part. So function signature is done. Now let's talk about me, my. Me, my is the, let's say equivalent of this is top and this is bottom, okay? So tell me what a me, my will be, or me and my children thing will be.
Like if first thing would be to check if the current coordinate is visited. Or
Okay.
if I am a valid coordinate, like if I am not a blocker, like if my value is 0, then only I can call on my children, something like that. And also, yeah, this only.
That's it. What is the me, my part? Like me, my children part. What am I asking my children?
Oh, do you have a valid path
Okay. So
starting you as my children?
what define valid path?
Uh, Valid path is any uh, coordinate in the matrix which is not out of bounds and which is not, the value is not 1. And also, if you have reached the last m minus 1, n minus 1, then those are kind of valid paths.
Okay, so let's put that into code. But before that, what direction is parent and what direction is children?
Children are the 4 possible directions.
Yeah, I understand. But I'm saying, so Hampe, when we were asking this here, so this is what we call a parent. And me, my was, I'm here. If somebody tells me all this is done, what will you do? Right? Add all your children is done, add yourself to the children, and then send it to the parent. You know, so children is on here. So where is the children in this case? let's say here is your current status, me, my, which direction is children and which direction is parent? I'm not even saying one of the four directions. Where do you start from?
0, 0.
Correct. So what is this called?
Parent.
Okay, perfect. So parent is asking a question to 0, 0. Is there a path from 0, 1, 0? And 1, 0 says,
Okay.
I have no idea. I'll ask my children.
Okay. Okay.
So children is, all I'm saying is you have to remember this parent and children is bottom up at this point.
Mhm.
This will be important when we switch this to the other two, which is recursion and memoization. Okay, so let's see. So let's write code. So let's write Python itself. So where did we go? We did me, my. So let's write the me, my code first. So let's do it doesn't matter which order, but we'll do top, bottom, left, right. Okay. So you said the first thing is what?
If first thing we can check if we have reached the end. M minus 1, M minus 1.
But that's your exit condition, right?
Okay, sorry. So,
Me, my, what is the first core logic?
okay, if my would be if my value is equal to 0, like if I am a part of a valid path, then you can, and if I'm also not the end, okay, that is the exit condition. Okay, if made grid of m comma m n is equal to 0.
Okay, hold on. So I'm just saying I'm replacing all that. Everything else here is going to become global. Okay. Assume I made it all global. Okay. So now I'll just make it IJ because that will be less confusing because all you have to do is ask your children what IJ is.
Mm,
But it's there. Assume visited is there. Assume grid is there. Assume m comma n is global.
okay, so if grid of I comma j
Hmm.
is equal to 1, then return false.
What does that mean?
It means that if my value is 1, it means I'm a blocker. The path cannot go through me, which
Other way
means,
around. No, it is 0 is blocking and 1 is good.
oh, okay, sorry. Yeah, then we
So
can just,
value 0 at the cell in the matrix represents that it is blocked. Yeah.
oh, okay. So if is equal to 0, return false.
Mhm.
Otherwise, so else, um, we will return. Basically, we will call on all the 4 directions.
Okay.
Before calling, either we can check if it is a valid coordinate or we can just call it in recursion and check an exit condition.
Okay. So you're saying, let's say these are the 4 children, top, bottom, left, and right.
Right.
What will you want to call here? Or what is the first thing you check?
If the top coordinate, which is previous row but same column, if that is less than m and n. So if I minus 1 is less than m and j is less than n, so like that. Yeah. So then we can call on top.
What do you mean by
But we
call?
need to save that value also, like t is equal to, we'll save that Boolean value.
Yeah, I will. But tell me what am I supposed to write here? T is equal to what?
Okay, we need to call the same method.
Okay, so we haven't even reached there, right? That is okay. That is parting gift. Me, my, just simply tell me the logic, like between top, bottom. I give you 4 children. What is your logic?
My logic is to return if any of my return like the or value of all the 4 children. Like
Perfect. So that will go top, bottom, left, R. Let's say we have 4 values here. So if you are you saying D or B
Yes,
or L or R,
yes.
you
Return
return what?
true.
Okay. And the whole function, what else would you return?
Uh, uh, false.
Okay, so at the end of the function, we can just call return false. Okay, so now the question is, so let's say we theoretically wrote the my condition. Now, what is my exit condition?
Exit condition is if we have reached the end, that can be one exit condition. If I is equal to m minus 1 and j is equal to n minus 1, return true. Oh, no, we need to check if the last value is also like 1.
What do you mean last value is also 1?
I mean, what if the m minus 1 n minus 1 value is 0 itself?
Okay, hold on. So let's say this is, okay. We have, right, Jesus. What is that stupid thing now? Oh, it had 1% battery, very smart. No, oh, Bluetooth. No. And what are you doing? Only draw with Apple Pencil. Okay, that looks good. Pen, chin, no, no. Now once. Stick it back in. Okay, no recognition. Something vanished. Something vanished. Click backtracking again. Okay, it's all right. Okay, so let's say we call this guy one jaw. Oh, right. Okay, I just need a different color pen. How bad is it? Okay, so this one 0 there. This one 0, 1, 2, 3, and here it is 0, 1, 2, 3. M is equal to 4, N is equal to 4. Okay, so what was your point?
I was just thinking, what if the last m minus 1 and n minus 1, the last block, what if that is blocked? What if that is 1?
Like, what if that is 0, right?
Yeah, what if that is 0?
But my question is, you would not have even come there if that is 0, right?
Oh, okay. Hmm.
Okay, so here what you've done is correct. Okay,
Okay.
if you have reached the last cell, you're done. You just return true. So let me reiterate how we are doing this. So, oh Jesus. All right, so this guy is gonna come this way, keep going. Like at 0, 0, he asks like it's stop. Top says no. Right says no. Left says no, and bottom says okay. Bottom says I don't know, but I'm gonna ask my children. So the bottom is 1 here. Bottom asks this guy. This guy asks this guy, and this guy left says no. Bottom says no. Right says yes, but before that, its top will come now. So how are we preventing the for
Yeah,
loop?
we need to check if I if visited of I comma j, let's just say every visited no, coordinate we mark as 0.
Okay,
So we will just check if visited of I comma j, if we have visited that, then we return false.
so this is if I minus 1 comma j less than m, and let's open it up itself. So you're saying I minus 1 comma j
Mhm.
is less than n. Okay,
Mhm.
and you want what?
And if I minus 1j not in visited. If it is not visited, then only we will call.
Yeah, so remember we created visited as a grid, double.
Yeah, so let's just use any value, like we'll default value will be -1, and if it is set as 1, we will consider.
Okay, so you're saying here you want to do the crazy thing which killed us a couple
Mhm.
of times. -1 for underscore in range of m, and this one
Yeah, uh,
for
for underscore range.
a range of n, you know?
Yeah, I think we have done it reverse, right? M cross n, so
That's okay. This is a matrix. The square matrix, it wouldn't matter, right?
okay, cool.
So let's say you're by default it's -1. Okay, so what
Yeah.
will you
So if the value is -1, which means it is not visited, then only we will call it.
okay, visited of I -1 comma j not equal to -1, is it?
Yeah,
Okay. So in that case, what do we do?
we will call the recursive solution on find path.
Okay, so basically then you're saying our exit condition is, where is it? So exit, you got done with the exit condition, okay, and you're writing the parting gift, right? Is that what you're saying?
Mm-hmm.
Okay, so let's say find path of Jesus. So you just want to do I -1 j. Okay.
Yeah.
So let's say we do it 4 times for each of the children T, B, L,
Mm-hmm.
R. Okay.
Mm-hmm.
So and
A few things missing, like we need to mark the current ij as visited. We can do that in before the if else, the second if else. We can just do I comma j, mark visited I comma j is equal to 0.
okay, comma j is
We'll,
equal to 0. Okay.
yeah. And mm, yeah.
There is a mistake here.
And the default values for TBLR can be false.
So we'll define T is equal to B is equal to L is equal to R is equal to false. Okay.
Okay, these are things I can think of right now.
Yeah,
Yours
okay.
thing.
Looks good, but there is a mistake here, which is
Mm.
very simple. Do you know what this is?
Which point?
You find out, you tell me.
Okay, okay. Visited IJs. 0. Um, Probably the first condition, if 0 comma 0 is false, that we can take care in the parent.
That's okay. That's the edge case and null check wave will come there. But I'm saying, so I'll give you a hint. It's got something to do with 0 comma 0.
The same thing, no? If 0 comma 0 is 1.
Okay, so
I don't.
that's okay. I'm saying you're here, okay,
Okay.
and you tried your top, you tried your right, now you try your left, and you went out of the grid, right?
Yeah, out of bounds. So we are checking that in the code, no? Before calling it to the left, we are checking if I minus 1j is less than m and I minus j is less than. We're doing that check.
We are not doing it. At least in this code, we are not doing it the way I have written it.
I mean, you told you will replicate T for BLR, and in T we are doing the out of bound.
This line.
Yeah, so you are checking if top is out of bounds, And if it is not, then only you're calling find path. This line, yeah, there's a bug. Like if you I minus 1 is less than m, we don't need to check j is less than m. Are you talking
Okay,
about?
so why are we not doing I greater than 0?
Oh, understood. Okay, sorry. Yes.
So you're checking if it's in the grid, and which is why I was saying just with the current thing you wrote, it will go out.
Right. Yes,
Hmm.
yes.
Same thing. So it can happen anywhere. It will go out from there. So even in that day, we want j greater than 0.
Yes. Okay.
I'm even thinking, let's write a new function itself called, this actually I learned from you, if is valid I comma j, and what will return is if I greater than 0 and I less than m and j greater than 0 and j less than n, return true, else return false. Do you agree?
I agree. Yeah, I agree.
Okay, so this one we can simply replace it with if is valid I comma j. Okay, if is valid I comma j. So we just find what the value sorry, I minus 1 j. This is dot, and we'll say we'll replicate it. Okay, I minus 1 j. Okay, and we are replicating it by 4 times when we write the actual code. Okay, are you done?
Yes.
Okay, so let's see that. Okay, cool. So let's do a dry run. Okay, so dry run means let's start again with the same grid. Okay, so make it bigger. Trying to clean it up a little bit. Okay, so let's say we are starting with the value 0, 0. Okay, so try run 0, 0. So you are going back your helper first. Helper. Okay, so in helper, we kind of rewrote this. So where do you want to start? It's only ij now.
0, 0.
0, 0. Perfect. Okay, so we come here. Okay, 0, 0. 0, 0, sorry. If I is equal to m minus 1, so m minus 1 is 3, I is 0, no. N minus 1 is 3, j is no, that's not returning true. We visited of I comma 0, j is equal to 0. So our visited, we never drew it. We might as well just draw it now, which is, where is visited? Okay, here. So let's draw a visited cell, which is minus 1, 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 minus 1. All right, so you're saying visited of 0, 0. If grid of I comma j is equal to 0, right? So not grid. So okay, visited of I comma j is equal to 0. That's the first thing you wrote. Okay, sorry. So let's go put that there. X 0, 0 is 0. Okay, so what is the next condition? If grid of I comma j is equal to 0, we are here and its value is 1, 1, 1, 1, 1. Okay, so it's not 0. That's fine. So visited, we did this. This is not happening, so not returning false. Okay, now we initialize top, bottom, left, right. If is valid of I minus 1 comma j, so that will be minus 1 comma 0. Okay, so let's go to minus 1 comma 0. Is valid, minus 1 comma 0 is I greater than 0. No, so this will return false. Okay, so it never goes to its top path, right? Because from at this point, top was going out of bounds. Okay. And then we will repeat it for each of these 3, and there your bottom, okay, so from here you first try top, then you try bottom, it's gonna keep going. But eventually, when you try left, that's also going to fail. Right is also going to fail because this value has 0 in it. So right is going to fail. Okay, so looks so far so good. So this is done, dry run. Okay, edge or null case, if we can add one in the helper, we'll just make sure that this is the one where you said you wanted to check if grid of 0, 0 not equal to, what do you want there? Okay, if it's 0,
It's not a blocker.
it's not a blocker. So if it's equal to 0, we return false,
Mhm.
return false, and else we'll go find asking questions. Okay, so I think we are, so far looks good to me. So let's try writing this up, coding this up, because what was our stage? Our stage was we finished edge null cases. We can type it out in online editor. So let me switch sharing. So let's share. Can you see the online editor now?
Yes.
Okay, so let's call it. Let's probably just use material itself. Wait a second. Alright, good. So let's see. So let's start with def helper. Def helper, I'll actually copy the grid from the actual question itself. So let's see, Java, Python 3. Okay, it remains whatever. What is next? Grid is given.
Visited.
No, I'm just m is equal to m. It's equal to 0. And you want to visit
-1, right?
Huh?
M is equal to len of grid -1. Oh, okay. Nothing. Please ignore.
-1 for underscore in range of
This is
L.
generally the column.
Okay, let me always write it down. This is rows, right?
Please.
Grid
I'm
of-
expense when I see M and N.
No, that's okay. So you're right. This should
Yeah,
be
yeah. This
right?
is correct.
Underscore in range of L. Okay, so we're creating visited. What else do I have to check? If grid of 0, 0 of 0 equals to 0. We call it find that of 0, 0. Okay, so let's call find.
Visited also. We'll
We call
pass.
it as global. Like maybe you know what we'll do? Screw this. Let's make all this global, so that way we can just call a.
But you can't return from not a function.
No, I'm saying why don't I do this? Def find path. Enough.
Yes, I'm just saying that line number 18 will not work.
This
Yeah.
return
Because,
false. Oh,
because you
sorry.
cannot return from not a function.
Fair. Okay, sure.
We can just print false. I mean, anyway, we are not using any grid with 0, 0.
So okay, no, if it's not equal to 0, we'll just do this. Okay.
Sounds good.
Okay, so let's do I comma j, and our first check was I'm literally copy pasting the code. Let's all follow our own logic, which is when we are going into child, if is valid something.
No,
so
Oh, you're stuck. Okay, I'm sorry.
I would rather write it in the same way, me, my first,
Okay.
into signature, me, my. So it needs def is valid, I comma j, and global, and global, and if I less than 0, j, 0,
So if we don't write line number 21 and 22, what's gonna happen within the, it's,
we'll run it. Okay, we'll run it and I'll show you what happens.
okay.
I created that. So is this correct?
I less than 0 or j less than or I, yeah. Greater than equal to
Which
m.
one? M, perfect.
I think all of, yeah, greater than equal to m, greater than equal to n.
Sorry,
Yes.
that's J. How do you write greater than or equal to this way only, right?
No, no, you have written it ulta, like, yeah.
Yeah. Okay, now
Ret-
you
Return true,
no.
false. Sorry.
It's not true. Also, though you have so many options. Okay, whatever. Is this valid? Wait, what are we doing? If I less than 0, we're checking for less ones. If it's close than I, yeah, okay, yeah, okay, take care, return true. Then or j less than 0 or I greater than or equal to m. No, that's not right. M is 3, so you shouldn't have, like in this case, 0, 1, 2, 3. It should be
So m is length. Length is 4.
4, so it shouldn't be equal to m also. There is no
Exactly.
4.
Yeah.
So what should I change?
Nothing.
Okay, let's see m, right? M's value here is 4. Do you agree? There are
Yes.
4 rows, 4 columns. Okay. Let's
Yes.
say I am here at 3, comma 3. And so 3, comma 3, what am I checking? From 3, comma 3, I can still go to +1, right? So shouldn't it be okay? I think you're right. Fine. Chalo, dekhte hain. I think you're right. Okay, let's go. Is valid. So let's, so top is I minus 1, comma j. Okay, so if it is valid, what is next? What would I write next?
If
Uh,
it's valid, then call find path. T, we will first initialize TLDR as false.
yeah, 1 second. So, okay. I just realized we did something stupid, which we don't know. Can we do this in Python, bottom left?
Yeah, yes, you can.
Um,
But you need to write false, comma, false, comma, false, comma, false, like that.
oh, that's what I asked. Okay.
Oh, okay. I think, yeah, you can do it.
Cha.
Capital F. Yeah, you can.
Well, apparently you can. Okay. So this should be outside because we are initializing it all for children here. Okay, so is valid I minus 1j. Okay. What are you doing here now?
We're calling T is equal to find path.
Okay, so let's not write that yet because that is our parting gift. So here, if at least one of them, if P or L or R is true, we return true, else we return false. Okay. So now let's go back to our exit condition. Exit condition is if I equals to m minus 1 and j equals m minus 1. Okay. And this one, all right, I is equal to n minus 1, j is equal to n minus 1. We return true. What else? We have to add the visited one. Okay. So I am in ij, I'm going to add a visited of I comma j equals 0. Visited of it's -1. Okay. If grid of I comma j. Okay, you have mentioned one more thing. If grid of I comma j is equal to 0, oh, that's the first thing. Where we should do this. Grid of comma j Ah, yeah, interesting. Okay, 0, return false. Is that correct?
If 1 second. Yes, so far, yes, visited. But in line number 40, then we will only call recursion if the I and j is equal to, it's not a blocker basically.
Not blocked. Okay. So you're saying there's one more check you need to do, which is if grade of I minus 1, comma j.
Oh, I'm just wondering, like, now I'm thinking maybe we don't need that. But in the dry run, we wrote it.
Yeah, in the dry run we wrote it. Why do you think we don't need that?
Because in line number 32, again, we are checking.
Fair argument, 0, 0, 0, 0, 1. So then we can just take this out now. We don't care about this guy now because the only thing we worried about was 0, 0, which we are already checking if 0, 0 is not equal to. Where is this grid of 0, 0? Okay, so let's do I minus 1 grid. Okay. And so what is next? T is equal to find path
Yeah.
of I
Yes.
minus 1, comma j. Syntax, nope, there's syntax.
And we also need to check if I minus 1 and j is not visited.
Just gonna leave it there and find out if you'll remember it. Set of I minus 1, comma j not equal to -1, right? We're initializing it in -1. All right, so let's see. We created it for top. We'll replicate it for all 4. Before that, let's try if this runs. This grid is equal to this. Okay. So even in this case, we need 2 things: local grid and local visited. Okay. So grid is here. M is equal to length of grid, N is length of grid of 0. Visited is -1 for I in range of. So I'm doing the read out loud part. Is 0 find path of 0 comma 0. Okay, find path of I comma j, global grid, global visited. If I is equal to m minus 1 and j is equal to n minus 1, we have reached last part. Visited is of I comma j is equal to 0. Visited of I comma j is equal to 0. Correct. When you just got here, you just added yourself as visited. Okay, sorry, no, this should be visited of equal to 0, right?
No, we marked as -1. So -1 means it is visited. So if it is not visited means if it is not equal to -1.
So we initialize it all with -1. And when we visit it, we are replacing -1 with 0.
So if it is -1, we can visit it. So
I now take the -1. You're right.
no. I think I'm wrong. So if visited I minus 1 j is equal to -1 if it is not visited. Yeah.
Okay, then only we visited. Fine.
Hmm.
Okay. So this is good. So visit global grid, global visited I is equal to -1, j is equal to n minus 1. TBLR is false. Is valid, go to is valid, I comma j, global m, global n. If I comma 0, j comma 0, I greater than or equal to m, j greater than or equal to n, return false, else return true. Okay, so just comment these 2 guys out to answer your question. Okay, so let's just run this because I want okay, where is it? Defined path is not defined. I just took it.
Because you're no, what happened? Yeah, because
This thing doesn't, it's a interpreter, not compiler.
line by line, yeah.
Um,
Sorry.
something, but
Okay, at least not an infinite loop.
you're saying global M or N is not needed. Oh, interesting.
No, I didn't know. I'm just curious. I never used it like I never used global a lot in programming questions.
No, I didn't know. I just literally took it like a safe from, I Googled how do you put global in
Okay.
Python, and this is what it said. Anyway, all right, so let's replicate it for our 4 children.
I will okay, I raised a maintenance ticket and the maintenance guy is here. So I will be away for 5 to 10 minutes and then I'll rejoin.
Yeah, by the time you do 5 to 10 minutes, I'll write this up.
Okay, I'm sorry, I'll be back.
All good. I plus 1j, I plus 1j, I plus 1j, I plus 1j. I'm left is I minus 1. No, left is j. I remains same. J comes to minus 1. ij minus 1. ij minus 1. ij minus 1. ij minus 1. Right is valid. I plus I remains same. J becomes next. J plus 1. ij plus 1. ij plus 1. Visited on I comma j plus 1.
I'm back.
Okay. Okay, so I copied everything as it is. Like basically top is the one we did, t is equal to find path of I minus 1j. Bottom is I plus 1j, I plus 1j everywhere. Is valid I comma j minus 1, I comma j minus 1. Is visited I comma j minus 1. Okay, j minus 1 is left. J plus 1, j plus 1, j plus 1, j plus 1 right. If either or at least one of my children says there is a path, I return true. Okay, so let's look at the grid again. The grid is you go here 0 0 1 0 2 0 2 1 3 1 4 1. See what is it? Whatever. There is a path 1 1 1 1 1 1 1. Okay, so let's run through. Okay, I'm gonna first try this. Okay, false, because I changed it to print false. Okay, very first step. So now I'm going to block a path for, I can just do this. My last thing is empty, edge cases, false. Okay, 1. And I am going to block this path.
No, even if you don't do like Okay, if you do undo 2 times, the path, the grid is still invalid. Like, can you do undo 2 times? Yeah. Yeah, now, even now, there's no path, right? Because it can't go diagonal.
Fair. Perfect. Okay, I think the code works.
Okay, no, can you make like that 57, yeah, basically have another path. I have another valid path. Yeah, something like this. Yes. Yay.
Yay. Okay, this works. My only suggestion is there is something you can optimize here. So grid is given to you as a two-dimensional matrix, but this is going to cost you so much, right? So every time you have to go check on I don't know.
I understand you're saying that we can use a set,
Yes.
which is a good argument. Yeah, and it's probably
Okay.
the better choice because the lookup is constant.
Yes, so I think this is good. So let's now go to the actual question. The question is, rat in a maze using backtracking. Okay. Up, down, left, right. They call it up, down, left, right. And the expected, they want us to print also, right? Not in a path. Source cell is 0, rat cannot move to any other cell. So source cell is 0. Okay, we checked the inner path. No cell can be visited more than one time. Okay. And what did you want to print? I consider it as find all possible paths a rat can take to reach from source to destination. Okay. So now if you want to find all paths, what will you do here?
We can.
Yeah, एक second. I'm very smart. Hold on. Now I want to check if all of this is right. Uh,
TLBR. Okay.
Zero.
We celebrated too soon.
No, this is a block, right?
This is a block, yes.
Yes, run false. Okay, it's fine. TVLR and just confirm couple of things. 0, run, 0, run. Okay, take it. It looks good, I think. What else was I saying? There is still no path. Correct. So let's keep it a path. 1, 1. Okay, cool. Think it works. Okay. What were we doing? I want to print the path. So what will you print?
We can. Oh, okay. How do we have to print the path? Like coordinates?
So can you see this? Yeah, coordinates is fine because they expect you to print down R, L, and all that stuff. Let's say for the sake of it, we'll print it as coordinates.
Okay, so
Asking all possible.
yeah, they're asking for all possible paths. They're only printing one, like.
No, that's correct. It's asking all possible paths that the rat can take to reach from source to destination. Oh, you're saying here we are taking only one path. So there's in this case there are two paths, you know. Go here and go right, or go this and go right. Good question. All right, let's start at least with printing the path we found, and let's see which one it does.
We can have a again we can have a set and we can keep appending coordinates to it, and we can pass that set to the recursion.
Why would you want to do such complication when you can simply put a print?
Okay. Yeah.
Simple solution is always the best solution, right? Like if we decided we are going into I-1j, so we might as well print it.
Okay.
Comma j plus 1. Okay. So there is a path. The path is 10202111. Let's see. Where is it? 00. Okay. 0010. 1021. It went here. 1. The fuck. 012. How did it go to 21? Interesting. Okay. 001.
21 is 1, right?
I'm saying from first it was 00. That is we're not printing. We can print 00 for the heck of it. Like, Wrong place. Wrong place. I'm just correct me. 0, 0, 1, 0. 1, 0 is first row. So 0, 0 it was here. First row, first column. Second row, this column. Then it goes to 2, 0. From 2, 0, it goes to 1. Okay. 2, 1, it goes to 1, 1. That's what I understand.
Yeah,
1.
because it will still that 1 1 is still valid, right? So it will go, but from 1 1 it will return false. So it will.
Okay, that's why it went back to 3, 1.
Yeah.
0, 1, 2, 3. Perfect. 0, 1, 3, 1. 3, 2, 3, 3. Okay, perfect. Yeah, looks good. Now let's see what do they want. They want to find possible paths to reach destination. Direction which art can move up, down, left, right. Okay, return the list of paths in lexicographically increasing order. What the fuck? DR, DDRR. But there's only one path. What do you mean by lexicographically increasing order? Matlab check.
Means that UDLR, right? So they want like that to be lexicographically sorted. Like
Like
for
left
example,
D should be first, then left, then right.
yeah,
Okay, boring.
boring.
Next is match using backtracking. Okay. But what I don't understand is in their solution, what is the expected answer? Expected answer is TTR, TTR. All right, let's try that now. At least that should be the easy part. Okay, we have to call it T. What top? What do these guys call it? Yeah,
TLDR,
that's
top down, bottom up, which is the same thing.
up, down, LR. So I just want to literally confirm like print up, print LR, LR, LR.
Mm,
TDRUDRR. TD.
is a matrix. Yep. Remember that 1 comma 1 was a blocker, but it still went to 1 comma 1.
DDR. Okay. Okay. We don't want to print it there. Yeah.
Yeah, how do we handle that?
DD is correct. R is correct. DRR is correct. This is what I'm saying. They want both the paths.
Yeah, they want
This is
both
the
the.
first path, and that is second. This okay. We are getting this right, so except for the mistake that if you go to the top, you don't want to print. I think it should print only when L is true. Let me check if say let's see here now.
Mm-hmm.
If there is a path, I print jar if the print down bottom right. Okay. I'm gonna print it only if there's a path. Okay, so technically it shouldn't go to up. Shouldn't go to up. P, up. What happened? It's E, path. Print D. It's not printing the first D. Okay. What am I missing? If L, then what do you think about this? I'm just saying, I was
Yeah,
trying to put the thingy, which is I want exact answer D, D, R, D, R, R.
yeah. Are we using the same grid? Because we changed the grid.
That's true.
DDR.
DDR, DRR.
Okay, have you put the alphabets correctly? Right, left, bottom, down.
Yeah.
seems active.
Okay, so then the question is there another path? No, what do they mean by lexicographically order it? Maybe they meant by that is like first check D and then. So I still don't understand what they are doing in their answer. Bottom of the cell,
So
okay.
our solution does not have backtracking, or does it have?
It does have, right? Backtracking is your visited thingy, basically.
Okay.
It goes back and checks. Right, so if you go back to our original,
No, but if there are two valid paths, our code only goes through one of
that
them.
I agree, that I agree. That I haven't thought of yet.
Okay, okay.
You'll have to probably restart it and then have another visited for that path or something like that.
Yes.
Our visited, all I'm saying is if you go from here, here, it backtracks. That's why we are saying it printed this, and then comes back and prints it again. And I was trying to avoid it doing that because if I go and if my child also says right, then only will I print this guy. Maybe. All right. Yeah, maybe we are wasting time on printing stuff. We are okay with the other one. So what do you think can we do to do it like all the paths?
Mm.
I'm thinking store this in a set and end may print it only if this guy is not in set. Like you said, we keep accumulating it instead of printing it immediately.
Mm-hmm.
And then this becomes part of a set, this becomes part of a hash set. And when by the time we get to here, all we check is that already created? No, but then the question is it as simple as one more for loop or is it something else?
What I know is like we will probably have to erase our visited.
No, even that we had to do. So that I agree, which we'll have to do in the initial for loop. Okay, so this is okay, okay, this one. Just trying to go back to where we were. Let's copy it again, and if I'll give it one more minute, if it doesn't work, we'll just move on to the next problem, which is the interesting part, which is the memoization of it. Okay, whatever, it's doing something, TK, TDR, U, DRR, and you're saying TDR, U is extra, DRR is fine. Okay, that's good. Okay, so now, yeah, if there are two paths, how will you print it, right? So I'm saying, what if we create something known as output? Okay, output equals to this. What actually happened here? This. Check print is equal to okay. So please feel free to correct me. My thought was we keep accumulating output, right? So we can keep output. Every time we find a path is valid, we just do output dot append. Does that sound correct?
Mm-hmm.
I'm going to the section dot output dot append. What do I want? Letter T top up.
But what we are not checking is if, okay, we are checking if this is a valid coordinate and we can access it. but we don't know if that is a part of our output. Like how we saw 1, 1, right? It was a valid coordinate, but it was not a part of the output path.
Okay, which is why I tried moving the if condition inside here
And
after
that also didn't work. Yeah. So now,
think about it.
mm,
One thing that doesn't work for me is if I look at the screen, it doesn't work. I really have to disconnect and look at the pen and paper. But I would suggest let's call that a homework, and then do you have time, Kya?
yes.
Okay, so I'm thinking that part we can just call homework, and then the more interesting part is this making it maybe recursive,
Mm-hmm.
or we have two choices now. Okay, either you can take rat, make it memo. What is memo here?
What
Wait,
is it?
tracking. There's no point doing memo, no? Okay, shit. All right, so maybe the visited is the only part, or go to your gold max problem and make it visited also. I don't think there is this concept called how does it help for loop? Yeah, okay, maybe it'll save time in that path if we replace for loop with the uh, 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 okay. Anyway, I'm thinking we'll just instead of trying to the goal was to finish this guy, right? The gold max guy. So why not just do this? And then we'll see. The idea was I wanted to touch upon gold max because that's what I'm thinking, not gold max. I want to touch upon visited idea, which I'm hoping will help us here in a gold mine itself.
I had visited, like, remember our solution had visited, but it was still not working. Like, I'm sure logic is incorrect, but we tried with visited.
This is your code, right? This is one we wrote. What is it? Without cache, pure recursion. Okay. And we use visited in that? No. Okay, maybe that is yours and this is mine. Okay, so this is your code visited 0 print as maximum value. You can't visit same cell more than one. Never visit a cell with 0 gold. Huh? Oh, submission. It was blowing up on something, right? Yeah, this is very weird. Yeah, I remember this problem. Okay.
Oh, you did. Nice.
Huh?
I mean, I see 40 out of 55. Wow.
Yeah, but I'm saying this one actually troubled me a lot. I wanted your help to find out. So this particular test case, now use test case, will say that this grid is 1, 2, 3, 4, 5, 6, 6 columns, 2, 3, 4, 5, 4. Okay, so this is columns, that must be 6. Print m comma n. So you're printing, what are you printing?
But your cache is incorrect, right? The way you wrote line 12.
This should be m first, yeah? That's what you're saying?
No, you ruled out, right? This is not the right format because it's
Oh, this is my other shit. Okay. Oh, maybe that is the issue. Like 0 for underscore in
rows, columns, sorry, columns.
it's columns and then we go row.
Yeah,
So,
maybe for the way you can remember is for first underscore, just write for column in range. Then you will know that you have to write column. Yeah. Yes, for row in range.
okay. Cache is 0. Okay. 0 in range. So I was using that and it ran everything else. Huh. Weird. There's a 10 cross 10. This is the guy which was failing. Okay. This is what I was saying. For a 10 cross 10. So this is your code or my code? I can't remember what
It is not it is not my code.
not yours. Oh, then I tried visited myself. Okay, okay. So visited dot add. Let me check. Gold mine DP. Oh no, this is the original gold mine. Huh. And that's smarter. Eh. Okay. So this one was very interesting because it passed 44 test cases. If you use this test case, This is a 10 cross 10 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So I cannot think of a reason why it would pass everything else and not 10 cross 10.
Mm-hmm.
If I greater than or equal to m, correct now? I should be
Right.
greater than if it is
The
returned.
row is, yeah, M, J,
Okay, let me read from top. Like, what are we starting with? Def the maximum gold, minor is my code. Okay, def maximum gold, length grid. Okay, print n, global max is 0. For ij visited is equal to set. So why do I have two loops there? Why do I have two loops there?
because you can start from anywhere.
Oh, that was the case in this case. Yeah, you're right. You're right. Okay, I called local max. So actually the output is 127 and it's 129. Okay, it's a way something very stupid. So local max print star, I'm printing what? Printing value of I comma j is 0, 0. Value of local max is 0. Acha, this also I was debugging. I remember this. Okay, so then global max, return global max. I'll return global max only when it is greater than local max. Okay, global max, return global max 132. $127. Okay. Okay, 127. So let's see what the grid looks like. Fuck, I tried even writing this somewhere. Wait a second, let me see if I have it somewhere just to find the path through it.
Can you scroll down from line number 24? Maybe I can look at it meanwhile.
Oh, we never finished reading it. Too. Sorry. If I comma j grid visited m and cache, I greater less than 0, I greater than or equal to m, or j less than 0, j greater than or equal to m, return 0. What is 0? Matlab that has no value. Okay. If
Hmm.
of this equal to 0, I'm not gonna go there. Okay, what is minor 2? Minor is the value, total value. Minor is the
That's the problem. See, if I is if it is 0, you can still collect it and use that path. You should remove line number 28 in my understanding.
okay, description. If grid never visit a cell with 0 comma gold, right?
Acha, never visit a cell. Okay. In the Geeks for Geeks, I think you could. Never visit a cell with 0 gold. Okay, cool. Then it's fine. Cache.
Okay, if cache of I comma j not equal to 0, return cache of I comma j. If grid of I j not equal to 0, if I j comma j is not in visited, that's my thingy, visited dot add I comma j. L is equal to self dot minor I comma j minus 1 grid visited m and cache. L right
Can
bottom.
you go scroll up? So you're checking if cache I comma j is not equal to 0. But what if you should check for if it is not equal to -1?
No, I'm initializing it with 0, no?
Oh, okay, cool. I thought you were using -1. So what if from I comma j the maximum gold you can get is 0? Then
Matlab, it's already in cache. We would not go to a cell if it has cache, right?
okay. Can
If
you
it
copy paste this code in the chat? I would
Ah,
want to debug in my and I can apply my stupid logic in my sleep.
no, that's okay. I'm saying is let's read this. Is something very interesting in this test case. Like if it passed 44,
Yeah,
understand what is
that's
wrong with
what I was saying. Like so
L
many more than 70% passed.
grid I of j is not equal to 5 comma j not in visited. Visited dot add I comma j. I don't remember writing this. I really wanted to write this with you, but okay, apparently I wrote this. You didn't write this, no? Visited dot add, or at least
I no, what the code which I sent, I also had like a visited array, but it's different than what you have written. Like I'll find it and send it again.
This one, okay? This is, I sent it to you. Why would I send it to you?
Yeah, this is your code. I'll send it again.
No, that's okay. I did it. No, you did the gold mine problem. I remember you sending me the chat, that wala problem. What is Geeks for Geeks? See,
Yeah, this one. Yeah, the screenshot.
hey, this is yours. Okay, maybe not. Okay. Global max is float of minus infinity. That is a very good idea. Do you think that matters? Okay.
You are initializing it as 0.
It really shouldn't matter.
Yeah.
How do you write it? Global max.
Float and brackets and it's string inf. So here you will use minus infinity.
This way?
Yes.
Should the minus be outside, inside?
No, it's this way. I know it's a weird syntax.
Oh my God. Okay. I don't think that alone is going to change. It's coming back to same test case. Okay. Global max, global max. But when you did this is the same place where we stopped, right? Is it? You are also using visited?
Yeah, and see, for me, it's even less test cases passing. So 22 only. And for me also 23, 24. I mean, I don't know what we're missing.
Hold on. This is I think no, here not this. Cache. Am I using cache, right? I'm using different thing called cache. Yeah, cache is there. Visited is. Take second. You have visited. Oh, this is your pure recursion solution, है ना? There's no cache.
I have DP.
What is DP? DP is your cache.
Mm.
Okay, so why do I not see if DP of, okay, maybe you're right. If DP of,
Oh, we're gonna have to use the
why are
DP.
you removing it from visited?
I am removing it. To explore all the possible paths.
Is that what they want? They don't want all the possible. Return the maximum gold. But I'm saying you're already doing a 4R comma C. So in a way, you are checking all paths within the different starting points. है ना?
Okay.
And let me check.
Let me remove it and see in my code.
In my return the maximum goal you can collect. Every time you locate and select from your position, you can walk one step. Like you can start and stop it from anywhere. Okay, so you have to go through all these grids. Okay. Max option 1 grid C DP comma C result. Result is equal to, oh yeah, we are adding the value to result. Cache out is equal to out.
If I remove visited dot remove, even then for me it's not working.
Only difference I can see here is between mine and yours is this explicit return zeros.
Okay.
If grid of I comma j not equal to 0, I'm returning a 0. If I comma j not visited, I'm returning 0. Theoretically shouldn't matter.
Because I have a long if statement in line number 16.
Acha, one second. Why is this not there for you?
If ij not, in my line number 16, I'm checking. If RC visited return 0.
Okay, that's also fine. Yeah, I think you're doing all of that also. So then I don't know.
But what is the difference?
Okay, so anyway, I sent you my code. The more problem is this guy that also will do homework itself, I guess.
Okay.
This troubled me so much. I was like, okay, what is 10 cross 10? What's so special about 10 cross 10? case 1, case 2, case 3 and all. Something weird with that test case. Chote mote, it's working fine. Why will it not work for this? Maybe because... Okay, if we write it down, this might... I'm just thinking if I had just written down somewhere. No, 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 no. I am not stupid, man. Fuck. After so many years of my life, I realize that now. For coding training. Okay. So what I did was, can you see my screen? This one, right? Yeah.
Yes.
Keep going, keep going, keep going, keep going. Acha. Yeah. Yep. So I actually rewrote the whole grid. Okay. So that's the 10 cross 10 grid I was writing.
Oh.
This is like 0, 0, 0, 0, 32, 0, 0, 20. Okay. Now our problem was expected is 129. My output is 127. Okay. And this grid is same thing. So when you, the way you get 129 is if you go to yeah, start with 13, go to 20, 36, 2. I see what happened. Okay, see. यहाँ से, so let me even rewrite it now itself. So this guy you see on the right hand side, right? I'm adding it all up. You know, so let me use different color. Maybe blue itself is good. Like 13, 20, 36, 27, 31. And it goes back here. Okay, so wait, where's it going? 27, 37. What is the value? 37. The value is 31, 27, 31. Okay. Okay, so let's rewrite this whole thing again. So I was trying to do share. So erase. Okay, just as going to do a try run on this, starting from 13. Okay, so starting from 13, we came, 13 is the first step. Then yahan se, first step 13, then it goes to 20. 20 ka, it checks, it's top, no, it's right, it goes to right first. Okay, I think my code goes to right first, right? Where it go? LRTB. Okay, LRTB. So L, okay, is visited. R, not visited. T. Oh, R was okay. Okay, so R, it went R. T. See T. LR, नहीं रे, एक second. LRTB. यहाँ से also it has to be LR. No. So यहाँ से it goes, checks L first. This is gone. R, it's 0, it's gone. T goes to 2. 2 comes here from 2. 3 is already visited from 2. L, R, T. B is the only options and 2 returns 0. So that is the mistake. So you know what I found here? So
No, I'm not able to see.
One second. So let me share the other thing. Machine, different machine. Got it. Share content. Screen. Still showing my என்னடா பண்ற? Okay, this will stop. Okay, other person screen share. Good. So all I was showing you was, okay, did you see this, what I was writing?
I was seeing, so whatever you were writing, I was not able to see. I was just seeing the 10 cross 10 matrix. I didn't understand why result is 129.
I know. I'll show you why the result is 129. So
Can you zoom out?
Yeah, इसमें से, so first I'm trying to show you the path my code took, okay?
Okay, okay.
So which is what I'm saying, it is LRTB. Okay, so LRTB. So when it was here, it went to the left first, left got an X, no answer. So it says I'm gonna not go there. R went, oh my God. Okay, so R, it went to 20. More thickness. Okay, more thickness goes to 20, doesn't help. Okay, anyway, L, it reverses, it's visited. R, okay, it goes to 3 again. Okay, 3 is visited now. From 3, L, no, it is not, it won't go there. R, 0, nahi gaya. Top, it went to 2. Okay, and from 2, we go LR, L. Can you see that? L,
Mm-hmm.
R, top. And 2 says, my all 3 neighbors, LRT is 0, and my bottom is 0. So 2 returns false. Okay.
2 returns max of all of it and itself. So 2 returns 2.
Good point.
Mm,
All right. Who returns 2? I mentioned J plus 1. I mentioned type over J. Okay. Yeah, you're right. But then I don't know anything. My thought was it was because it went
mm,
to 3, 27, and 31,
mm.
of which there is a 2
Okay,
it did not add.
understood.
Unless
Um,
something else I'm missing in a path which is I'm missing. I don't think so. A second, let me just make sure the grid has any other path. Sure. Maybe the grid might have another path which we're not looking at, but this is 127 is max. Huh. It found that the cache is not empty for given I value 3 and j value 1. Going to return value 31. Where do we want to go? 31. Oh shit, I'm not sharing that now. Sorry, I'm sharing the wrong screen. Go back here, share screen. What do you see in your screen now?
mm,
Lead
lead
code.
code.
Okay, so starting is 2 comma 0, value of I comma j is 2 comma 0, 1, 2 comma 0, correct. 2 comma 0, value of local max is 127, global max found cache is not empty for given value 3 and j. I can even print this, it will be hot mess, but I'm going to just print L. Where is 127? Okay. Value of ij is 2, 0, to local max 0. Okay. So it found 13. It found, what do you want? 13, 20, 3, 2, 13, 13, 23, 2, 27, some other path. Ari, then this is, oh, something is wrong. Grid is different. Yeah, what is the grid? Maybe I wrote it wrong. Cha, that's the problem. Did I write it wrong? 31, 27, 0, 0, 32, 32, you have 0, 0, 13, 20, 36, 0, 13, 20, 36, 0. What the F? Oh, wow. I'm calculating it right, but I wrote it wrong. Sorry. You're seeing the screen now where it just should be 36, not 13, but still 36. Okay. Okay, so 36, 0. It should really go 13, 20, 36, 27. 13, not even 127. It didn't go there. It's some other path than I'm missing. 13, 2. What the? 13, 20, 36, 00. 13, 20, 36, 00. Started at 13. 2, 0. 0, 1, 2, 0. Okay. Why is it printing 4 left, right? Because this is 4, 4, 4, 4. Okay, maybe. यहाँ से it goes to 0, 0, 0, 2, 2, 31, 58, 94. 2, what the? Where is my code going? Okay, then there's something screwed up in my code most. All right, so what the? 94. What is it printing? Hash of 5, hash of 5 is 0.
Maybe you can stop the recording also.
It can, huh?
Yeah,
Okay, stop
it will
it.
be heavy otherwise.
Now did the screen sharing also go?
Screen sharing.
How smart. I stopped screen sharing instead of recording. Okay,